Hello Year 11s, this is the refinement of the Further Maths June 2023 paper 2, which was the calculator paper. Question 1, solve. I'm going to cross multiply. So 2 lots of 8d minus 3 equals 5 lots of 3d minus 7. 16d minus 6 equals 15d minus 35. I'm going to subtract 15d and add 6. Gives me d is equal to negative 29. You would get 1 mark for either of these brackets. 1 mark for this line once you've expanded. Full marks for d is equal to negative 29 as your final answer. Question 2. The first 4 terms of a linear sequence are this. Find the nth term. You can see it's going up in 3.5s. So it's going to be 3.5n, and then if I go back 3.5 from 15, I get 11.5, so it's 3.5n plus 11.5. You'd get 1 mark if you had 3.5n anywhere, and full marks for 3.5n plus 11.5. 2b, a different linear sequence has this nth term. Work out the value of the first negative term. Negative term means that this is less than 0, so I'm going to make 318 minus 9n less than 0 and solve. I'm going to add 9n on both sides and divide by 9. Gets me 35.3. Means that the 36th term will be the first term to be negative. So the 36th term is when n is 36, so the value of the 36th term is 318 minus 9 lots of 36. Gives me negative 6. You would get 1 mark for forming an inequality, like this. 1 mark for getting up to this line, dividing 3 by 9, and then full marks for, sorry, it's only 2 marks. 1 mark for forming your inequality, your second mark is for negative 6 as your final answer. Question 3. Work out the values of t and u. I know that if I multiply top by column, that will get me this value. So 3 times 1 plus 5 times 4 must equal t. So this is going to be 3 plus 20, so that's 23. 23, so t must be 23. And then bottom row times column, so that's u times 1 plus 2 times 4, so that's u plus 8, must equal bottom element 6. So u plus 8 is equal to 6, so u is negative 2. You'd get 1 mark for each of those values. Question 4. A line passes through P, 1k, and Q are 6, where k and r are constants. The midpoint of PQ has x coordinate 5. The gradient of the line is 2. Find k. Okay, I'm going to draw a sketch of what's going on. So P has coordinates 1k, so it's somewhere on this line. I don't know what the y coordinate is, but it's somewhere on this line, x equals 1. Q has coordinates are 6, so I don't know the x coordinate, but the y coordinate is 6, so it's somewhere on this line. The midpoint of PQ has x coordinate 5, so the midpoint is somewhere on this line. If the midpoint is somewhere on this line, I think it's going to have to be like P over here and Q kind of over here, otherwise this is not going to be the midpoint somewhere on this line. So I think this must be P somewhere over here. So this is going to be 1k, and this must be Q over here, R6. The midpoint is somewhere on this line. The gradient of the line is 2. Okay, so my midpoint is somewhere here, and it's halfway between P and Q. I notice that I've got the x coordinates for P and the midpoint. So I know that this change, which is from 1 to 5, this is 4, must be the same as this change. So from 5 I'm going to have to add another 4, so R must be 9. because I must be going the same distance from the midpoint. So 5 plus 4 gives me 9. Okay, what else could I do? I know that the gradient is 2, so I've worked out that I'm going all the way from P to Q. I'm going along 8, which means if the gradient is 2, then I must be going up 2 lots of that. Along 1 up 2, along 1 up 2, along 8 up 16. The change in y must be twice the change in x. So if this value is 6, then to work out this value, I must need to do 6 subtract 16. Okay, must be 6 subtract 16, which is negative 10. You would get 1 mark for working out this value 4 anywhere in your workings. There's lots of different ways you could have done this, but if you're using this method. You'd get another mark for figuring out that the r coordinate is 9. You'd get 1 mark for doing 6 subtract 16, and then full marks for negative 10 as your final answer. Question 5. Y equals 0.5x to the 4. Work out the value of x for which the rate of change of y with respect to x is 6.75. This means, rate of change of y with respect to x, this means dy by dx. So I want that to be equal to 6.75. So I'm going to need to find dy by dx first of all. So dy by dx, so that's going to be 4 times 0.5x cubed, which is 2x cubed. And I want that to be equal to 6.75. So I'm just going to solve to find x. Dividing by 2 on both sides. X cubed is 3.375. And then cube rooting. X is 3 over 2 or 1.5. You would get 1 mark for 2x cubed. 1 mark for getting as far as x cubed is 3.375 or 27 over 8. And full marks for 3 over 2 or 1.5 is your final answer. Question 6. The equation of a circle is x plus 7 all squared plus y minus 4 squared equals 36. Complete these statements. The coordinates of the centre of the circle. I know the centre comes from this stuff and it's always the inverse. So the x coordinate is negative 7 and the y coordinate is positive 4. The radius, I know that this is r squared, so the radius is the square root of 36, so 6. You'd get 1 mark for each of those. Question 7. Here's a sketch of the curve y equals ax squared plus bx plus c. A, b, and c are constants. Intersects the x-axis at negative 4, 0 and p0. Turning point has x coordinate 0.5. Work out the value of p. I can see this is one of the roots. And I know that the turning point for a quadratic is always equidistance, halfway, midpoint, between the roots. So I know that this distance from this root to the turning point, negative 4 to 0.5, is 4.5. This is 4, this is 0.5, the whole distance is 4.5. So this distance must also be 4.5. So p is going to be 0.5 plus 4.5 plus 4.5, which gives me 5. 1 mark for that. Solve ax squared plus bx plus c is greater than 0. Greater than 0, so I'm going to highlight the stuff above the x-axis, which I can see is when x is less than negative 4, or when x is greater than, I worked out p was 5, so when x is greater than 5, you'd get 1 mark for each of those. Question 9. ABC is a triangle with perpendicular height AD. Area is 25 for ABC. BD to DC is 2 to 3. Work out the size of angle W. Okay, I'm going to start with that area thing. I know the area of a triangle is half times base times perpendicular height, and they've given me the perpendicular height AD as 4. So I know that a half times base times height is equal to 25, and I know the height is 4. So a half times base times 4 is 25. So half times 4, that's 2. So 2 times the base is 25. So the base must be 12.5. So this distance, BC, must be 12.5. I've then been given this ratio BD to DC, 2 to 3. I think to find W, I'm going to focus on this right-angled triangle where I could use SOHCAHTOA with, I've got the opposite, and if I could work out DC, I'd have the adjacent. So I'm going to see if I can find DC. To do that, if I divide this 12.5 in the ratio 2 to 3, I'll be able to get DC. So 2 to 3, I've got 5 parts altogether, is worth 12.5, so I'm scaling up by 2.5. Scaling up the, I only really need the 3 bit, the DC bit. There's my DC bit, BD. By 2.5 I get 7.5. So this distance is 7.5. I'm going to draw out that triangle. 4, 7.5. I've got the opposite and the adjacent, so I'm going to use tan. So tan W is 4 over 7.5. So W is tan to the minus 1 of 4 over 7.5. Gives me 28.07. For angles, unless they don't state the degree of accuracy they want, go to 1 dp, so 28.1 is what I'm going to write as my final answer. You would get 1 mark for forming an equation involving the 4 and the 25. You would get 1 mark for scaling up the 3 by 2.5 using ratio. You would get 1 mark for tan W is 4 over 7.5, and full marks for 28.1 as your final answer. Just give you the range that you could have had for that. Anything between 27.9 and 28.4, you would get the mark. Question 9. The dimensions of the cuboid are given in centimetres. The total length of all 12 edges is 300. Show this. Okay, so I think I need to add together all the edges, and then I'll have an expression involving, or an equation, sorry, involving y, and it looks like I need to make y the subject to show the thing they've asked for. So I've got 4 lots of each of these edges. 4 lots of x plus 2y, 4 lots of 2x, and 4 lots of 3x. So I've got 4 lots of x plus 2y plus 4 lots of 2x plus 4 lots of 3x, and that is equal to 300. Expanding. And collecting like terms. And making y the subject, because that's what they want me to show. So 8y. I'm going to divide through by 4 at this stage, because these are all divisible by 4, not by 8. So dividing through by 4. And now I'll divide by 2 to get it into that form they want. So y is 75 minus 6x all over 2. You'd get 1 mark for this line. And then all of this is your next mark. For a show that question, you just need to make sure that every line is accurate, there's no little slips, and you haven't just like fudged it at the end. So all of this is to get that second accuracy mark. Part B, the volume is V. Show that V is this. I know that the volume of a cuboid is going to be the 3 dimensions times together. So 3x times 2x times x plus 2y. So 3x times 2x times x plus 2y. I notice there's no y in this, so I think they've replaced y with this, 75 minus 6x over 2. So I'm going to write this as 6x squared x plus 75 minus 6x over 2 times 2 lots of y. So that's 6x squared x plus the 2's can cancel. So 75 minus 6x, so 6x squared, 75 minus 5x, multiplying out, 6 times 75 is 450, minus 30x cubed, which is the thing they asked me to show. You'd get 1 mark if you got as far as this line, and then full marks for getting up to this line with no errors. Part C, use calculus to work out the maximum value of v. Calculus means differentiate, and I'm going to be differentiating v with respect to x. At a maximum, my gradient function, so dv by dx, is equal to 0. So I'm going to differentiate this. Let's do that first. dv by dx is going to be 900x minus 90x squared. I'm going to now set that equal to 0. So 900x minus 90x squared equals 0. Can divide through by 90. 10x minus x squared is 0. Factorise out x. 10 minus x. So either x is 0 or x is 10. Because x is a dimension, it can't be 0. So x must be 10. But they want me to find the value of v, not just x. So I'm going to work out what is v when x is 10, and I'll use this to work out v. So v is 450 lots of 10 squared minus 30 lots of 10 cubed. Type that into my calculator. I get 15,000. 15,000. You don't need to include units, but if you do, they must be correct. Centimetres cubed would be the units. You would get 1 mark for either 900x or minus 90x squared. You'd get 1 mark for setting that equal to 0, and then full marks for 15,000 as your final answer. Question 10. Line K has equation 4x minus 5y equals 17. L passes through 3, 6, and negative 5, 16. Tick the correct statement. Parallel, perpendicular, neither parallel, perpendicular, show working. So I think I need to work out what the gradient is of these two lines. I'm going to start with line K. 4x minus 5y equals 17. And I'm going to make y the subject to work out the gradient. So I'm going to add 5y on both sides. Subtract 17. And divide through by 5. I'm going to write this as 4/5 x so that I've got the coefficient of x, or m, just in front, and really easy to identify. So the gradient of k is 4/5. I'm going to do the same now for L, using y2 minus y1. 16 minus 6 over x2 minus x1 minus 5 minus 3 is 10 over negative 8. Simplifies to 5 over negative 4, which is, I can write the negative in front, negative 5/4. So m is negative 5/4. Okay, I can see they're not parallel because they've got different gradients, and I can see that 4/5, the reciprocal of that would be 5/4, the negative reciprocal would be negative 5/4, so they are perpendicular because one is the negative reciprocal of the other, or if I multiply them together I'd get negative 1, so perpendicular. You'd get 1 mark for either this line or this line, rearranging to make y the subject. You'd get 1 mark if you had both 4/5 and negative 5/4. And 1 mark if you've ticked perpendicular, but you only get that mark if you've got both of those method marks. If you've just ticked that box with no workings out or wrong workings out, you won't get that third mark. Question 11, expand and simplify. Okay, I'm going to expand my first bracket, so I'm going to get 6x to the 5 plus 8x cubed minus 27x squared minus 36. I'm going to write this as x minus 4 times x minus 4. So I've got that x outside, and then x squared minus 4x plus 16. So that's going to be x times x squared minus 8x plus 16. So that's going to be x cubed minus 8x squared, plus 16x, multiplying each term by x. And I've still got my 6x to the 5 plus 8x cubed minus 27x squared minus 36 plus. collecting like terms, I've got 6x to the 5. There's no x to the 4s. X cubes, I've got an 8x cubed and an x cubed there, so that's plus 9x cubed. X squared, I've got a minus 27x squared and minus 8x squared, so that's minus 35x squared. X's, I've just got my plus 16x and then minus 36. You would get 1 mark if you had that first expansion of the first two brackets with at least 3 terms correct. And you'll get 2 marks if you have all 4 of these terms correct. You will get 1 mark if you get up to here, where you've expanded the x minus 4 all squared and multiplied each term by x. And then full marks, or the fourth and final mark, for 6x to the 5 plus 9x cubed minus 35x squared plus 16x minus 36 as your final answer. Question 12. VABCD is a pyramid. The square horizontal base ABCD has side length 15. V is directly above the centre x of the base. VA is 28. Work out the size of the angle that VA makes with ABCD. So here's VA, and I want the size of the angle that makes with this plane ABCD. I'm going to see if I can draw a right-angled triangle where this is going to be one of the sides of that right-angled triangle, and another of the sides is going to be lying in the plane ABCD. To figure out what that triangle would look like, I imagine taking this side and dropping it like a pen, taking that side VA and dropping it into the page, where that would land. So if I took this side VA and I dropped it into the plane ABCD, it would land kind of like this. And if I were to construct a right-angled triangle, what I'm going to do is just drop this directly. So I've dropped this. My right-angled triangle is going to be this triangle, VXA, where this is the right angle, because VX is vertical and AX is a horizontal side. So that's going to be the triangle that I'm going to be able to find that's going to give me the angle between VA and ABCD. The angle that I'm going to need to find is this angle, so I'm going to call that theta. I'm going to draw that triangle out so I can see it clearly as if I'm looking at it from this direction. So it's going to look like this. Here's X, here's V, here's A, labelling my vertices. Here's my right angle. VA I know, VA I'm told is 28. I don't know any other lengths though, so I'm going to need to find at least one other length in order to be able to work out this angle, angle theta. I'm going to focus on this side AX, which is part of this triangle, triangle ABC, triangle ABC. And again, I'm going to draw that out to one side as if I'm looking down on it. Labelling my vertices, A, B, C. AB is 15 and it's a square-based pyramid, which means that all of these edges are 15. So BC is also 15. So AC is going to be the square root of 15 squared plus 15 squared. Gives me 15 root 2. That was AC. So AX, if X is the midpoint, it's going to be halfway between A and C, because this is exactly in the middle of the square, in the centre of the square. So I know AC is 15 root 2. So AX, this dimension, is going to be a half of 15 root 2. Or let's call that 15 over 2 root 2. I've now got enough information to find this angle. I've got the adjacent and the hypotenuse. So I'm thinking of cos. So cos theta is 15 over 2 root 2, adjacent over hypotenuse, 28. So theta is cos to the minus 1 of 15 over 2 root 2 all over 28. Type that into my calculator. You get 67.7. They don't tell me a degree of accuracy, but to 1 dp is good for angles. Okay, you would get 1 mark for working out AC is 15 root 2. You would get 1 mark for cos theta is 15 over 2 root 2, sorry, over 28. And then full marks for an angle between 66.9 and 68.435. (13a), circle the expression equivalent to 3x to the negative 7. I know that's the same as 3 times 1 over x to the 7, which is the same as 3 over 1 times 1 over x to the 7, which is the same as 3 over x to the 7, which I can see is this term. So that's the one that I'm circling for 1 mark. B, simplify fully. I'm going to first square that denominator, so I've got 12w to the 8 over 16w to the 6. Now I'm ready to simplify. 12 over 16 I can divide through by 4, becomes 3 over 4. W to the 8, w to the 6, I'm just going to end up with a w2 in the numerator. So I've got 3w squared all over 4. Any equivalent form? So if you had 0.75w squared, that would be fine. I'm just wondering if you'd get, yeah, that's kind of the only other valid way you'd get it. You'd get 1 mark if you'd expanded your denominator, and then full marks for 3w squared over 4, or 0.75w squared as your final answer. 13c. Root y times cube root y equals the cth root of y to the power of d, where c and d are positive integers. Work out the least possible values of c and d. Okay, I'm going to think about another way I could write this using indices. So square root of y is the same as y to the half. Cube root of y is the same as y to the third. And if I multiply them together, that's the same as adding the powers. So that's y to the a half plus a third, which is adding, I need a common denominator, so I'm going to multiply by 3 in the numerator and denominator, so y to the 3 over 6 plus multiplying by 2, numerator and denominator 2 over 6, which gives me y to the 5 over 6, which I can write. I know that my denominator tells me the root and my numerator tells me the power, so I could write that as the 6th root of y to the 5. It could be bigger power, so it could be any multiple of this. So for instance, it could be y to the 10 over 12, which is why they've said the least possible value. Or it could be y to the 50 over 60, any equivalent fraction to this. But these would be the smallest possible values that c and d could be. So c is going to be 6 and d is going to be 5. You would get 1 mark for getting to this stage, so y to the half plus a third. In fact, sorry, you get you get 1 mark for just writing y to the half or y to a third. Either of these gets you 1 mark. You get 1 mark if you get to y to the half plus a third, so that gets you 2 marks if you get to this stage, and then full marks for 6 and 5 as your final answers. Question 14, simplify fully. See, I've got algebraic fractions, so I'm thinking about factorising, and these two, denominator and numerator, look like they can factorise. So I'm going to leave my numerator alone, 15a squared over. This can factorise two numbers that multiply to negative 16, add to 6 are 8 and negative 2, so a plus 8, a minus 2, times, this one I can pull out a common factor of 4, lots of 2 minus a, over 3a. Okay, I'm ready to simplify, and I can cross-cancel some stuff. So I can cancel through a factor of 3a here and here. So 3a, this just becomes 1. Dividing through by 3a, this is going to become 5a when I divide through by 3a. I'm going to put all of that together now. So I've got 5a times 4, lots of 2 minus a, all over a plus 8 times a minus 2. And I can see these two factors are almost the same, but they're not quite, because this is positive a minus a, negative 2, positive 2. So what I'm going to do is I want this factor to be a minus 2. So I'm going to write this as 5a times, I want that bracket to be, instead of 2 minus a, I want it to be a minus 2, which means I've divided through by negative 1. So timesing by, I'm going to pull out a factor of negative 1. So if I had a 4, that's going to become negative 4. This numerator is now exactly the same. If I multiplied it out, I'd still get a minus 4a, and I'd still get a positive 8. Minus 4 times minus 2, I'd get a positive 8. So I'm happy that my numerator is still the same. Over a plus 8 times a minus 2. I can now see a common factor. Terms are separated by addition and subtraction, so this is one term because it's just multiplying. So I can divide through by that a minus 2. So I'm going to be left with 5a times minus 4 is minus 20a all over a plus 8, and that is as simple as it can go. So my final answer is minus 20a over a plus 8. You would get 1 mark for dividing through by the 3a, so getting the 1 and the 5a. You would get 1 mark for correct numerator, for factorising your numerator. So this 4 lots of 2 minus a is enough for 1 mark. You get 1 mark for factorising your denominator, so if you get a plus a minus 2, that's another mark. And then your fourth and final mark is for getting this as your final answer. If you've written it, there's a few other forms you could have written it. So you could have the minus in front, or in the numerator as I wrote it, or your denominator as minus a would also be fine for full marks. Question 15. The function g is given by this. Gx is a times b to the x, where a and b are constants. The domain of the function is x is between negative 1 and 2. P is 0, a half. Q is 1, 3 over 2. So this point must be 3 over 2. And they are points on the graph. Work out the range. Okay, I know that range is everything to do with y. So I want to work out what is this range. To do that, I can see there's no funny turning points, so I think I just need to substitute in negative 1. So figure out what's y when x is negative 1 to get my lowest point, and then positive 2. Work out what's y when x is positive 2 to get my highest point. But to do that, I'm going to need to figure out a and b to work out what my function actually is. And I think I'm going to use these points to work out a and b. I'm going to start with this point. So I'm going to rewrite my function as y equals a times b to the x. I know it passes through 0, a half. So I'm going to substitute x as 0, y as a half. So a half equals a times b to the 0. I know that anything to the power of 0 is 1, so this is just going to be 1, so a half is equal to a. I'm going to do the same thing now with q. So 1, 3 over 2. 1, 3 over 2. So 3 over 2 is equal to, I've just worked out a as a half, so a half times b to the 1. Anything to the power of 1 is itself, so 3 over 2 equals a half b. Timesing 3 by 2, so 3 is equal to b. Now I've got my function, so my function is y equals a half times 3 to the x. So to figure out this smallest value, I'm going to substitute in when x is negative 1. So x is negative 1, y equals a half times 3 to the negative 1. I can use my calculator, but 3 to the negative 1 is a third, so that's going to be 1/6. So my smallest value is a sixth. My biggest value is when x is equal to 2, and that's when y is a half times 3 squared. So a half times 9, so 9 over 2. 9 over 2. The range is y, but there's no y actually, oh no, there is. So I could either use y or gx, either y or gx. And I'm going to follow the convention. It was greater than or equal to, greater than or equal to, which means it's greater than or equal to, greater than or less than or equal to, as my final answer. You would get 1 mark for substituting in 0 a half to get this. You would get 1 mark for finding a is a half and b is 3. You would get 1 mark for a half times your value of, well, your value of a half, your value of 3 to the negative 1. And you also need this, a half times 3, so you need both subbing in negative 1 and subbing in positive 2 to get that method mark. And then your final mark is for getting this as your final answer. So y is between a sixth and 9 over 2. If you've written g of x, that's absolutely perfect. If you've written x, though, instead of y, you won't get that final mark. So you'll only get it if you write y or g of x, because the range is for y, which is equal to g of x, not x. (16) 2x minus 3 is a factor of this. Solve. This is equal to 0. I notice that these two are the same, so I'm thinking factor theorem. Sorry, give all solutions as exact values. Factor theorem. So if 2x minus 3 is a factor, then I can use polynomial long division to find my next factor. So I'm going to divide 6x cubed minus 25x squared plus 28x minus 6 by 2x minus 3. 6x cubed divided by 2x is 3x squared. Write that above my x squared term. Now I multiply. I'll write the steps, sorry. So divide, multiply, multiply, subtract, drop. So I've divided 6x cubed by 2x is 3x squared. Now I multiply. 3x squared by 2x is 6x cubed. Multiply. Minus 9x squared. Now I subtract. Write my line, write my subtract sign. These terms will always just cancel out, so I'm just going to go straight to the minus 25x squared minus 9x squared. That's negative 25 plus 9, which is negative 16. I've got a calculator, so I'm just going to double check. 25 plus 9 minus 16 x squared. Now I drop. Plus 28x. Now I go back to the start, dividing this term by 2x. Negative 16x squared divided by 2x is negative 8x. Now I multiply. Negative 8x times 2x is negative 16x squared. Negative 8x times negative 3 is positive 24x. Now I subtract, line, subtract. These always cancel, so I move straight to 28, subtract 24 is 4x. Now I drop, minus 6. And go again for the last time. 4x divided by 2x is plus 2. Multiply, multiply. 4x minus 6, subtract 0, 0. And then nothing to drop. If I don't get a remainder of 0, I've gone wrong. I would go back and check my work. So I can write this as 2x minus 3 times by this, 3x squared minus 8x plus 2. 3x squared minus 8x plus 2. And I'm ready to solve. So that's equal to 0, which means either 2x minus 3 equals 0, in which case 2x is 3, x is 3 over 2, so that's one solution. Or 3x squared minus 8x plus 2 is 0. And I'm going to use the quadratic formula. I don't think that will factorise. They said exact values. So I'm going to use the quadratic formula and I'll just leave my answer in surd form. So x is going to be minus 8 plus minus square root of minus 8 squared minus 4 lots of a lots of c all over 2 lots of a. Type that into my calculator. Okay, 4 plus root 10 over 3, leave that exact. 4 plus root 10 all over 3, plus root 10 all over 3, and probably minus for the other solution. Let's just double check. Yep, 4 minus root 10 all over 3. You'd get 1 mark for getting up to the minus 8x, so 3x squared minus 8x with your long division. You'd get another mark for getting 3x squared minus 8x plus 2, so we've got that whole quotient, 3x squared minus 8x plus 2, that's 2 marks. You'd get 1 mark for either subbing into the formula, so this line, or if you've used completing the square, you'd get up to this 4/3 plus minus root 10 by 9. And then full marks for all 3 of these solutions given in exact form, so not writing them as decimals. If you've written these ones as 4/3 plus root 10 over 3 or 4/3 minus root 10 over 3, that's also fine. And any equivalent fraction, obviously 1 1/3, 1 1/3, writing this as 1.5 or 1 1/2 will be fine. Question 17. The function h is given by hx is this, where a is a positive constant and h is an increasing function for all values of x. Work out the possible values of a, giving your answer as an inequality. Values. Okay, I know that an increasing function means it's got a positive gradient, so that means dy by dx is greater than 0. So what I'm going to do is see if I can differentiate this and then set it set it as greater than 0, and then I'll get an inequality that I can solve for a. So I'm going to write it as y, so y equals ax times 3x squared minus 2 plus 5x. I remember that when I want to differentiate, if I've got brackets or fractions, I always expand or simplify first. I'm going to expand this first. So that gives me 3ax cubed minus 2ax plus 5x. Now I'm going to differentiate. Dy by dx is 9 9a x squared minus 2a plus 5. So if it's an increasing function, then my gradient is always positive, so this is always greater than 0. So 9ax squared minus 2a plus 5 is greater than 0. And I'm going to see if I can solve to find some values of a. This feels quite unfamiliar. I've got a kind of quadratic inequality, but I've got two unknowns. I've got like a and x. So I'm not sure what to do from here, but what I notice is I want this to be greater than 0. And I notice that I've got this x squared term. Whenever I square something, it will always be greater than or equal to 0. So this thing, this x squared, is always going to be greater than or equal to 0, which means that this whole thing, if a is positive, which it tells me a is positive, this whole thing is always going to be positive because I've got something squared, which is always going to be positive or 0, times by something positive, so it's always going to be positive or 0. So this bit, 9ax squared, is always going to be greater than or equal to 0. So if I want this whole thing to be greater than 0, I'm happy with this bit. This is already definitely going to be greater than or equal to 0. So what I need to make sure is that this thing, the minus 2a plus 5, is greater than 0, so that the whole thing is greater than 0. So I'm actually just going to ignore this term and jump for the minus 2a plus 5. This bit must be greater than 0, because this bit is already definitely greater than or equal to 0. So I'm just going to solve this bit. So I'm going to add 2a to both sides, dividing by 2. Okay, so a must be less than 5 over 2, but a is a positive constant, which means it must be greater than 0. Whoops, greater than 0. So it's greater than 0, but it's less than 5 over 2. So my final answer is going to be a is greater than 0 and less than 5 over 2. You would get 1 mark for expanding and having the 3ax squared and the minus 2ax terms. You would get 1 mark for differentiating. You would get 1 mark for setting your differential as greater than 0. So actually, even if you didn't get that sort of weird bit at the end, you've got 3 out of 4 marks. And then your fourth and final mark is for getting this as your final answer. Question 18. Here's a sketch of y equals cos x for values of x from 0 to 360. Alpha is obtuse, measured in degrees. Cos alpha is negative k, k is a positive constant. Tick 2 boxes that show expressions for x where cos x equals negative k. Okay, so I can see that I've got cos x equals negative k, where x is alpha here, and then I've got this other value over here. And I want to find an expression for this angle, for which cos of this angle is also negative k. You can see a few ways I could work this out. So I know that this distance is alpha, and this distance is also going to be alpha. So this angle I could say is 360 minus alpha, I can see that another way I could get this angle is I could think about like this distance. So first of all, 360 minus alpha, let's see if that's an option. Yes, here, so let's tick that one. So we've got one of our boxes. The other way that we could get to this angle is we could go from like the 180 and see how far we need to go. So I know that this distance, so this distance is alpha, so this distance is going to be 180 minus alpha. So this distance is also 180 minus alpha. So this angle is also, I could think of it as 180 plus 180 minus alpha. Oh, that's going to just get me 360 minus alpha. That's going to get me the same thing. So let's think of another way we could get there. Maybe using the 270, because I can see... Is that going to be 180 plus 180? Yeah, it's going to be the same as 360 minus alpha. So... Well, the next value for which cos x will equal negative k is actually, if I continued this, there's no restriction. There's no restriction on x. They've given me a sketch of values from 0 to 360, but they haven't said that x is between 0 and 360. So I think x can actually be beyond this. I'm going to continue my graph, and I'll get another angle over here for which cos of this angle, whatever this angle is, cos of this angle will also be negative k. Cos of that angle will also be negative k. This angle is just a repeat of this angle, so it's this plus, I've done another full cycle, so it's alpha plus a full cycle is 360, so this angle is going to be alpha plus 360, or 360 plus alpha, so that's this one here. You would get 1 mark for each of those, identifying each of those. 18b, circle the expression for x where sine x equals negative k. Sine x equals negative k. Okay, I'm going to draw on, I've got my negative k drawn on, and I'm going to draw on the graph of sine x. So the graph of sine x, I know it passes through 91. This one, 180, 0, 270, minus 1, oops, like that, and 360, 0, and 0, 0, so it goes like this. And I want to find the value of x when sine x equals negative k. So when sine x equals negative k, you can see that's like here. And I've also got another value here. So I'm going to think about what this could be. And I can see it's like this little distance. It's like 180 plus this little distance. So I'm going to see if I can find an expression for this little distance, which I can see is the same as this little distance here, which is, if that whole distance is alpha and that's 90, it's going to be alpha minus 90. So this little distance is alpha minus 90, which means that this angle here is going to be 180 plus that little distance of alpha minus 90. If I simplify that, the 180 minus 90 becomes 90, so I've got 90 plus alpha. Let's see if that's an option. 90 plus alpha, yes, this one is going to be the one I circle. 1 mark for that. 19. In these simultaneous equations, k is a positive constant. Solve them, give your answers in their simplest form in terms of k. Okay, so I've got simultaneous equations. They're both linear. There's no yx or x squared or y squared. But I'm going to use substitution because y is the subject of one of them. So I'm going to replace y with 2kx in that equation. So I've got 3x plus 4 lots of 2kx equals k. Expanding, so 3x plus 8kx equals k. And I want to make y the subject. I'm solving an equation. I can see I want to get x equals y equals. So making x the subject, I can factorise out an x. 3 plus 8k. So x equals k over 3 plus 8k, which in its simplest form, that can't be simplified any further, and that's in terms of k. So that's my answer for x, k over 3 plus 8k. And now I'm going to see if I can find y. So I'm going to use this equation, y equals 2k lots of x, k over 3 plus 8k. I'm going to multiply the numerator by 2k, so that's going to give me 2k squared over 3 plus 8k. Again, that can't go any simpler, so I can leave that as my final answer. You would get 1 mark for eliminating y, so showing this is your first step. And then 1 mark for substituting your value of x into y. And then full marks for these as your final answers. If you had eliminated x, I'll just show you that method, you'd get something like this as your first step, and then subbing in your value of y into your equation for x, and you'll get the same final answers. Question 20, show that 2 sine cubed x plus 2 sine x cos squared x plus 5 tan cos x simplifies to p sine x, where p is a constant. This is trig identities, so I'm going to make a quick note of my trig identities, which are sine squared plus cos squared is 1, and sine over cos is tan. I can see this is what I want my final answer to look like, so I'm going to see if I can rewrite some of these in terms of either sine over cos, if I've got a tan, or maybe replacing cos squareds with sine squareds, etc. The first thing I'm going to do actually is I can see that these first two terms share a common factor of sine, so I'm actually going to pull out a common factor of sine x. I'm going to write sine x's as s's, cos x's as c's, and tan x's as t's. So I'm going to rewrite this as 2s cubed plus 2s squared, sorry, 2s, not s squared, 2sc squared plus 5tc. I've got a common factor of s in those first two terms. I'm going to pull that outside of a bracket. So I've got s lots of 2s squared plus 2c squared, and then just plus 5tc. 2s squared plus 2c squared, I've got a common factor of 2, I'm going to pull outside of a bracket. 2s lots of s squared plus c squared plus 5tc. S squared plus c squared, that is just 1. Sine squared plus cos squared is 1. So that is just 2s times by 1 plus 5tc. So I've got 2s plus 5tc. I know that tan is sine over cos, so I'm going to replace tan with sine over cos. So this is 2s plus 5 times sine over cos times cos. My coses can actually cancel. I can think of this as cos over 1, and my coses will cancel. So I'm going to be left with 2s plus 5s, because my cos is cancelled. These are both just sines, so 2 lots of sine x plus 5 lots of sine x gives me 7 lots of sine x. My final step is just to write that in terms of sine x, not s. So 7 sine x, which is in that form, p sine x, where p is a constant. You would get 1 mark for if you got up to this stage, where you've pulled out a factor of sine, or this stage where you've pulled out a factor of 2 sine. You would get 1 mark for rewriting tan as sine over cos. And your final step is for getting to 7 sine x as your final answer. (21) A, B, C, D, and E are points in a circle centre O. Work out the value of x. This question is giving circle theorem, and I can see potentially some angles at centre, angles at circumference. Maybe cyclic quadrilateral, although I've not actually got a cyclic quadrilateral, I've got a kind of cyclic pentagon. I can also see some isosceles triangles. So the first thing I notice is that this is isosceles because I've got 2 radii. So this angle must be 2x, and I'm going to write my reason each time as I go, because not always, but usually they want reasons for circle theorem questions. So this is 2x because base angles in isosceles triangle are equal. And I'm just going to see if I can keep going. I'm not necessarily focused on the end goal, but just what could I find from here. I've got 2 angles in a triangle, which means I can find the third angle. So this angle is going to be 180 minus 4x. 180 minus 4x. Again, I'm going to write my reason just in case this is one of those ones where they wanted reasons, even though they didn't ask to give reasons. So the reason is angles in triangle sum to 180. Okay, where could I go from here? I've got these 2 shapes which are both, they're not like cyclic quadrilaterals because not all 4 points are on the circumference, but I have got angle at the centre, angle at the circumference. So this whole angle, I'm going to actually do it down here. So angle, maybe I can do it in a different colour. Let's go for that. So this angle and this angle are actually an angle at the centre, angle at the circumference pair. I'm going to label this angle as angle DOB. Angle DOB is going to be 2 lots of 6x, so it's going to be 12x, and the reason is angle at the centre is 2 times angle at circumference. I've worked out this angle is 12x, and I know that this angle is 180 minus 4x. So what I could do now is work out like this angle here, which would be the whole green angle, so 12x, subtract this kind of black angle, the 180 minus 4x. So that's angle AOD. So angle AOD is going to be that whole green angle, 12x, minus the black angle, 180 minus 4x. 180 minus 4x, which expanding, I'm going to get 12x minus minus 4x, so that's going to be 16x minus 180. 16x minus 180. Where could I go from here? So I've got now this angle, AOD, 16x minus 180. I could work out now, I've got another like angle at circumference, angle at the centre. Have I got another colour I could use? Yes. So this whole angle is another like angle at the centre, angle at the circumference. I'm going to call this angle AOD, but it's like the reflex angle. So this one, let's call this the obtuse angle AOD, and now we're doing the reflex angle AOD. And just so I keep track of my work, that was the sort of green one that I shaded, and the obtuse one is this purple one. So I've got a 7x, so that angle is going to be a 14x because angle at the centre is double angle at the circumference when they're like facing the same direction. So that's going to be a 14x because angle at the centre is 2 times angle at circumference. And finally, I think I've got enough information now to maybe form an equation and solve to find x, because I can see I've sort of got angles around a point at this stage. So let's take my purple one that I just worked out, which I just worked out was 14x, and then this green one is 16x minus 180, and they add together, so they're two angles around a point, so they add together to make 360, because angles around a point sum to 360. So I can form an equation now. 14x plus 16x minus 180 equals 360, because angles at a point sum to 360 degrees. And I can now solve this equation. So I've got 30x minus 180 is 360, so 30x equals 180. So dividing by 30, x is equal to 6. Whoops, no, that's a shame. Very silly. Adding 180 on both sides. 360 plus 180 gives me 540. I'm actually going to use a calculator because I'm making lots of careless slips. 360 plus 180 is 540, and then dividing by 30 is 18. Is 18. X is equal to 18. Okay, you would get lots of different ways that you could have solved this. But if you'd use the method I've used, you would get 1 mark for getting 180 minus 4x, this expression. 1 mark for getting 12x minus that, so getting up to here. 1 mark for forming an equation, so getting to this line. And then 4 marks for getting 18 as your final answer. There are different ways that you could have done it, so I'll just project the mark scheme if you used a slightly different, had a different path to that. These are your kind of options. Okay, they didn't actually, for that one it looks like we didn't need to write our reasons, but it's just quite random. Sometimes they want the reasons even though they don't state write your reasons, so just always for these kinds of questions write your reasons in just to be on the safe side. 22. 5-digit integers are made using these. For each integer, all digits are used exactly once. The integers are greater than 40,000 and odd. How many different integers can be made? Show your workings. Okay, so I've got 5 places to fill for 5. And if it's greater than 40,000, then this first digit could be 7, 8, or 9. And if it's odd, then my last digit could be 1, 7, or 9. And I'm actually going to split this because there's 2 options. If my first digit was odd, then I'll have just 2 options here. But if my first digit was 8, then I'll have 3 options here. So I'm going to split this into numbers that start with 2, 3, 4, 5. The numbers that start with an 8. And if a number starts with an 8, then I'll have all of my odd digits available for that last place, 1, 7, or 9. So if that's the case, I'll have 1 option for my first digit, and I'll have 3 options for my last digit. I will have used 2 digits, so I'll have 3 for my second, 2 for my third, and just 1 for my fourth digit. And I'm multiplying those together to find the number of numbers that start with an 8, end in a 1, 7, or 9, have the other digits in between. So that's going to be, in fact, I don't know, 3 times 2 times 3 gives me 18. And then I've got my options that start with a 7 or a 9, which means that my last digit will be either a 1 or a 7 or 9, whichever one's left. So there's going to be 2 options for my first digit, and there's going to be 2 options for my last digit because one of the odd digits has been used up in that first place. I've used up 2 digits, so these numbers are going to be the same. 3 options for my second, then 2, then 1. Timesing together gives me 8 times 3, 24. Finally, I need to add together 18 and 24. Gives me 42 as my final answer. You would get 1 mark if you had 18 or 24, or there's a few options you could have done this. 18, 24, or 12, or 54, or 72 would all be 1 mark. If you have both 18 and 24, that's going to be 2 marks. Or if you had 18, 12, and 12, if you've done it into like ones that start with an 8, ones that start with a 7, ones that start with a 9, that's how you'd get that. Or the 18 and the 24. And then full marks for 42 as your final answer.